VCI is equal to what? Anyone? Sorry, not VCI. VCJ is equal to what? Anyone? Yes, 0. And we also know VBJ is also equal to what? 0. Now there are a few, or there are rigid body. Okay, so identify the rigid body first. So members, BDA, and members CDE are rigid body. Okay, declare first. Okay, so we are going to now make a guess. Okay, we're going to assume directions of omega AB and omega ZE. Okay. Okay. So I'm going to assume. So this is where you assume. Okay. So can you see what's going to happen? So if we were to slide A down, right? If A were to slide down, member BDA will rotate in clockwise or anti-clockwise. Anyone? Clockwise, right? It makes sense. So you have to physically do it. Okay, don't just like sit down there, right, in the term test, not knowing what to do, right? And you know when the piston A or the slider A is coming down, BDA will rotate in the what? Clockwise direction. Okay, clockwise. So we assume this to be clockwise. Okay. So this is our omega AB. And then I have now, what is really confusing me now is I have not a clue, right? So I have not a clue how omega CDE will rotate. I really what? I really don't know. Okay. So I'm going to assume them to be rotating this way. So this is my omega CE. Okay. Down here, I'll put bracket that we are very sure. Are you very sure? Yes or no? Are you comfortable? Because it's coming down. Omega AB is going to be in a what? Clockwise direction. Omega CE, unsure. It's okay. Okay. And then what are you going to guess? Point C is going towards the left or point C is going towards the right? Anyone? What do you prefer? Yes. Left. Okay. Okay. So this is our VCI. Okay. So the rest, we don't know, we are unsure. And then we're going to assume that VBI is in this direction. And then we put in our transformation. X, Y, rotation about Z. Okay? As I said, we have to start from somewhere. Okay? Okay. So we are going to find VC. Okay, we're going to find VC. And one thing we have to take note, okay, note that VC only have what? I component. Okay, it does not have J. So let's look at VC first, okay? So you can form equation from VC or from VA, is up to you. So I'm going to form the equation from VC first, okay? So VC is equal to VD plus by omega CD cross omega C, oh no, omega, you just, so really, R C from point where? D, okay? So VC is what we want to determine. Okay, VC is what we determine. So in order to use this equation, we don't have omega CD, right? So omega CD, okay, so we can also write that omega CD is also equal to omega CE, okay, because they are a rigid body, okay? So this is our equation number 1. So the next thing that we want to find VD. Okay, so to apply this equation, to use equation 1, we need to determine VD and omega CD. Okay, so we know VD. So now we are focusing on point D now. Okay, we are focusing on point D. So VD will be equal to what? Will be equal to, I'm going to use point A now. Why I'm going to use point A? Because point A can help me what? Determine the velocity at point A, okay, which is given. So we know that we can use VA, right, plus omega AD cross R D from point A, equation number 2. Okay. Now, one thing for sure, we know that at this instant, okay, at this instant, all right, at this instant, VDI and VDJ are not equal to what? 0. Okay, I want you to like highlight on this. Okay, I want you to focus on it. At this instant, VDI and VDJ are not equal to what? 0. Okay. The previous example is equal to 0 because the velocity vector for BBJ is what? Coming down perpendicular. For this case, I have not a clue. You cannot assume it to be equal to 0. I really don't know. Okay, but don't know does not mean it's equal to what? 0. Are we clear? Okay, you cannot say we don't know. Make it easy. Let's do 0. Okay, we can't do that. Okay. So now the dilemma comes like, hey, we have too many unknowns now. Yes or no? Right? But watching it further, we already declare that member BDA, right? BDA are what? Rigid body. Can you still recall what do we mean by rigid body? Anyone? That it will not bend, yes or no? Right? The structure or member BDA and member CDE will not what? Will not bend. So in this instant, we can maybe do this. Okay, we maybe can do VB is equal to what? Is equal to VA plus by omega AB cross R A B. Equation number 3. Okay. So hopefully from equation number 3, right? The good news about equation number 3 is this. Okay, what is the good news about equation number 3? We know this, right? We know this. We don't know this. But what do we know? Note VB J is equal to what? It's equal to 0. Okay, so that might cancel some things away from us. Okay, so let's use equation number 3 first. Okay, let's use or apply equation number 3 first. Okay, so VB we don't know. Oh, sorry, VB. We know VB. There's only going to be what? VBJ, right? And VBI. And we know that VBI will be what? Positive. Okay, so positive VBI is equal to VA is equal to minus 4J plus omega AB. So omega AB is minus omega ABK cross. So R, right? So we want to know, sorry, I got it the other way around. Can you change this, please? My bad. Point B from A. So this is A. We are going to determine point B. Okay. So if you see the ratio, so the length, okay, so before we do that, we do some side work. Okay, so the side work member AB is equal to what? Is equal to 550 millimeters. Okay, and we know this angle over here, right? So the I component is equal to what? Is equal to 4 over 5 multiplied by 550. Okay, so 4 over 5. So now we are looking at distance now. Is equal to 440 or 440 millimeters. And this is where from point A, right? So this will be negative minus 440 millimeters. And then J is 3 over 5 multiplied by what? 550. 3 over 5. So it's equal to positive 330 millimeters. Okay. So from here, we can write point B, okay? From point A, the I is what? So the left-hand side is minus 440I or 0.44I plus it's positive is 0.33J. Okay, I'm going to stop here. I'll see you guys tomorrow.